A self-diplexing antenna designed using SIW technique for C-band applications. Abstract, the paper explain how the substrate integrated waveguide can often used to implement a self-diplexing antenna for C-band applications. The designed antenna exploits two quarter mode SIW cavity resonators. Quarter mode SIW cavity resonator is attained from the half mode SIW cavity resonator by dividing with the assistance of one open-ended slot. Each quarter mode SIW cavity resonator is excited separately using microstrip feed lines. The antenna display two resonant frequencies of 6.44 and 7.09 GHz, with the subsequent gain values 4.8 and 6.2 dB respectively. Moreover, the antenna shows unidirectional and stable radiation diagram operating frequencies. The obtained frequencies are ranging between 4-8 GHz, so the designed antenna can be used for C-band applications. Keyword substrate integrated waveguide, SIW, self-diplexing antenna, quarter mode SIW, MSI. 1. Introduction. Nowadays wireless communication systems leading a serious role in communication, especially the software-defined radios, demand a compact, lightweight, high-performance dual-band or multi-band antennas 1 to 2. SIW technology already experienced a rapid development over quite one decade. This development allows demonstration and applications of innovative passive and active circuits, antennas and systems at microwave and millimeter wave frequencies 3 to 5. Some multilayered structures are want to improve the isolation between the input ports 4 to 5. In 6 and 7 using non-planar configuration the antennas with self-diplexing capability are implemented. Substrate integrated waveguide is implemented to beat the drawbacks of microstrip and DFW, dielectric filled waveguide. Dual T-stubs loaded apertures are developed in 8 using self-diplexing antennas. SIW techniques are often utilized in many antenna designs to urge high performance at very high frequencies. SIW technique can be combined with other 6 platforms to create multi-format and multi-function devices and systems. Using SIW cavity-back self-diplexing antennas are demonstrated 9 to 10. 1.2 HMSI and KMSI. It occupies large space because of the full-wave SIW antenna. A big miniaturization of the SIW antenna is achieved by applying the SIW, HMSI, and SIW quarter mode, KMSI, half-wave mode 11 to 12. The HMSI has almost the equivalent distribution of the E-field as the full SIW, although its size is half that. KMSI is attained by dividing the HMSI into 2 parts. Figure 1, HMSI and KMSI. 2 Design and Analysis 2.1 Design. The specification proposed is prototyped using the copper laminated RT/Duroid 5880. Substratum 1.57 mm thick, dielectric constant 2.2 and loss tangent 0.0009. In this proposed design, HMSI resonator operating in dominant mode is split into 2 unequal parts by etching a one open-ended slanted rectangular slot. This slot transforms HMSI into 2 unequal quarter modes like cavity resonators. Figure 2, Design of self-diplexing antenna using SIW technique in HFSS. The required dimensions for the planning of this antenna are given below with schematic configuration of antenna. Figure 3, Schematic of antenna configuration. Table 1, Dimensions of antenna configuration. 2.2 Analysis. 1 Port 1 only excited. When the planning is completed, the supported measuring configurations, it's simulated using an soft HFSS simulator by exciting only port 1 by microstrip line feeding at a frequency of 6.44 GHz, and port 2 is terminated employing a terminator. The maximum gain obtained is 4.8 dB. Figure 5, 3D gain plot. The above figure represents that 3D gain plot where it ranges from -19.4 to 4.8 dB. 2 Port 2 only excited. When port 2 only excited by microstrip line feeding at a frequency 7.09 GHz and terminating the port 1. The utmost gain obtained is 6.2 dB. Figure 7, 3D gain plot. The above figure represents that 3D gain plot where it ranges from -19.2 to 6.2 dB. 3. Both port 1 and port 2 are excited when port 1 and port 2 are excited at a time with two different operating frequencies, i.e. 6.44 and 7.09 GHz. This exhibits the nature of self-diplexing antenna as it is working at two different frequencies. Figure 8, S parameters plot. When both port 1 and port 2 are exited at simultaneously, there exist four S parameters present. Those are S1,1 is 7.0111 dB at frequency -14.17 GHz, S1,2 has two values -45.67 dB, -45.49 dB at frequencies 6.34 GHz, 6.95 GHz, and S2,2 is -17.07 dB at frequency 6.611 GHz. Figure 9, 3D gain plot. The above figure represents that 3D gain plot where it ranges from -9.2 to 3.6 dB. 3. Conclusion: a self-diplexing antenna using SIW technique for C-band applications has been successfully designed and simulated using HFSS. 2. Quarter mode cavity resonators, placed orthogonally to every other, are used for radiation. The quarter mode resonators are acquired from half mode SIW resonator by inserting a slanted one open-ended rectangular slot. Each quarter mode resonator radiates independently, at the corresponding resonance without affecting other. The measured and simulated results show a depth agreement with one another. The obtained resonant frequencies are often used for C-band applications.